Hey guys, today I am going to talk to you about the atom and the subatomic particles that make up an atom. Before I do, make sure you have your highlighter and your pen or pencil and follow along with the notes. So the average atom has a diameter of 1 × 10⁻⁻⁻ meters. A common unit used for atomic mass is angstrom, which means that 1 angstrom is equal to 1 × 10⁻⁻10 meters. That means that an atom is really tiny, super tiny. So you've got your subatomic particles that make up the atom. You've got the proton, neutron, and electrons. The proton is located inside the nucleus, and it has a mass of 1 AMU. That is atomic mass unit. So if atomic mass unit or AMU confuses you, think of it this way. As when you talk about weight, you talk about pounds, grams, kilograms. So those are all unit measurements. The unit measurement for atom is AMU because we're talking about something that is very small. The charge for a proton is +1. And then we have the symbol for the proton. The neutron is also located inside the nucleus, and it also has a mass of 1 AMU, atomic mass unit, and it has a charge that is neutral. And then we have the symbol for it. The electron, as you know, according to the quantum mechanical model, is located inside the electron cloud. The mass of an electron is 1/1000th AMU. That means that this electron, that all electrons have such a small mass that it really does not contribute to the total mass of the atom. We often say that the mass of the electron is negligible, meaning that it is insignificant to the mass of the atom. That is done by the proton and the neutrons. Okay? However, the electron does contribute to the charge of the atom, just like the proton. And then you have the symbol for the electron. So the first one, the definition we can come across is the atomic number. So you have your atomic number, which is the number of protons in an atom. And the atomic number is what determines which element an atom is. So this is really important because when you were trying to identify the atom or identify the element, you were always going to look at the atomic number or the number of protons. So you all have a periodic table that you should have printed out with the notes. And if we use our periodic table, so go to your periodic table, and I'll zoom out for you so you can see the entire periodic table. So if you're looking at this periodic table, let me move this paper. If you're looking at the periodic table, it's made up of many tiles. And each one of these squares is an element. And the number on the very top, for example, if you are looking at hydrogen, let's look at carbon instead. That's what I have. So if you're looking at carbon, the number on top is your atomic number. The C is the symbol of the element, and then this number right here is your average atomic mass. And that is true for every single element that you have here. So all carbon, it always has 6 protons in it. Okay, and that's what distinguishes, if you find an atom that has 6 protons, you automatically know that it is a carbon atom. That's what distinguishes it. So if you go back to your notes, the tile right here, you've got your atomic number, you've got your element symbol, and then you have your average atomic mass. Okay, so moving on, let's look at mass number. Let me zoom in. Okay, there we go. So if you're looking at mass number right here, Mass number is the number of protons plus the number of neutrons. Okay? So you have the number of protons plus the number of neutrons equals your mass number. So there are two different notations that you can use for mass number. And the two different notations are, the first one is you can either write the symbol of the element or you can write the name of the element. And then you are always going to have a dash like you do here. And then you're going to have a number. Now this number is important because this number is your mass number that you have. Okay? Second way to actually write this is that you can write the symbol of the element again, and then you can just write the mass number on the top left-hand corner. And once again, that number is your mass number. So you can write it two ways, your notation for it. So if we look at this, we have lithium. And if you look at your periodic table, we have lithium 7. Okay? So if you look at your periodic table, we've got lithium right here. Notice that lithium has 3 protons in it. So we're going to have 3 protons for lithium. And if we want to find out how many neutrons it has, remember that the mass number is equal to the number of protons plus the number of neutrons. So if you already know how many protons it has and you know the mass number, then you can simply subtract it from it. So 7 minus 3 would tell us that there are a total of 4 neutrons in lithium. The next one we're going to look at is isotopes. So isotopes is the atom of the same element but with a different number of neutrons. Okay? That's really big, the different number of neutrons. So even underline that to make an emphasis. Okay? To make an emphasis. So we've got lithium 7, and then we've got lithium 8. So using your periodic table, we know that lithium has 3 protons in it. So we're going to write 3. And then we're going to try to figure out how many neutrons it has. 7 minus 3 is now going to give us 4. And then 8 minus 3 will give us 5. So notice here, you've got the same number of protons. You've got 3 protons for lithium 7 and then 3 protons for lithium 8. What does differ is the number of neutrons. Lithium 7 has 4 neutrons and lithium 8 happens to have 5 neutrons in it. Go ahead and either stop the video and complete bromine, arsenic, and strontium, or you can just look down and work on this in your paper, and then look up when you are ready to check your answers. Remember, you are looking for the number of protons and the number of electrons and neutrons. So use your periodic table in this case. Okay, look up, and when you look up here, you've got bromine 80 has 35 protons and 45 neutrons and 35 electrons. Arsenic 75 has 33 protons, 42 neutrons, and 33 electrons. And then strontium 88 has 38 protons, 50 neutrons, and 38 electrons. So the one thing that I didn't talk about is electrons with you. So let's go back real quick. So let's talk about what a neutral atom is. Nowhere in here in this question does it say anything that these elements have a charge. So we're going to assume that they are a neutral atom, and that is where the number of protons happens to equal the number of electrons. So over here, when we go to bromine 80, you've got 35 protons, and you've got 35 electrons. When we go to arsenic 75, you've got 33 protons, 33 electrons, and so forth. Okay? Now, talking about atomic mass, the atomic mass is the weighted average of the masses of an element's isotope. And I will talk about atomic mass in more detail in the next video, and I'll actually talk to you about how to calculate the atomic mass also. Okay? But let me go back to this neutral atom and talk about protons with you. Okay? So go further down in your notes and look at where it says ions. So an ion, right here, an ion is when an atom gains or loses electrons. And why is that so important? The reason why that is so important is whenever you have a chemical reaction, ions are always formed. And that's really important, so put stars around it, do something. So you remember that whenever a chemical reaction happens, you have ions that are formed. An ion happens to have a net electric charge. Okay? So what does that mean, a net electric charge? That means that a cation is produced or formed that is positively charged ions. And then an anion are negatively charged ions. Okay? So if we talk about this in a little bit more detail, let's go back to these notes that I have written. You can write these also on what an atom is. So there are really three types of charges that an atom can have. The first one is a neutral atom, and we don't really consider that, but we'll talk about it. So a neutral atom, as you know, is the number of protons is equal to the number of electrons. So it's a balancing act. When you have the same number of protons and the same number of electrons, no one charge takes priority or is greater than the other. So you have the same number of protons and the same number of electrons, or same number of plus and minus charges. So really you're going to have a zero charge, and we say that it is no charge, and that is a total of zero. So it's a neutral atom because everything is balanced. A cation, on the other hand, is where it loses electrons. And when it loses electrons, it becomes positively charged ion. And the notation is usually the element symbol, the number of electrons that it has lost, and then we put a plus sign to say that now you have the atom is has more protons than electrons. That's because it has lost those electrons. The third type of charge is an anion, where it gains electrons, and we say that this is negatively charged ions. Again, an element, symbol, the number of electrons that it has gained now, and now because that it is more electrons, we say that the ion is negatively charged. So if we go back to your notes, right here, give you a minute or so. So if we go back to your notes, and now we're going to do those example problems where it says determine the number of electrons and protons in calcium, 2+, iodine, phosphorus, and carbon. So you can always pause the video now or look away and finish your problems, and then when you are done you can look up and we'll talk about it then. Don't forget to use your periodic table to find the number of protons. Okay, look up. So if we're looking at this, we've got calcium 2+. That means that this calcium, because it's a 2+, that means that this calcium has actually lost 2 electrons. Okay, so it's the loss of electrons. So according to our periodic table, calcium has 20 protons in it. So we've got 20 protons, and then it's lost 2 electrons, so it's got 18 electrons. We've got iodine. Iodine, according to your example, is 1-. Now, because it's the number 1, we can either leave it as a negative sign, and that is true for if it was +1, we could just leave it as a plus sign. But because the number 1 is understood, but just to make it clear to you right now, I will go ahead and put that number 1 there, so it's 1-. So you've got the proton, 53 protons, and because it has gained 1 electron, that makes it a total of 54 electrons. Phosphorus has 15 protons in it, but it has now gained 3 electrons, so it's now 18 electrons. Carbon has a total of 6 protons in it, but because it is 4+, that means it has lost 4 electrons, making it a total of 2 electrons. Now, if we look at the symbolic notation of nuclide, that is the notation on how to write all of this. And I've actually talked about it. Remember that the letter X represents the element symbol, and then on the top left-hand corner we write the mass number, and on the bottom we write the atomic number. Okay, the bottom left-hand corner, and then on the top right-hand corner we write the charge. Okay, and remember the charge is usually a number, and it's usually followed with a plus or a minus sign. So if something, remember we talked about a neutral charge, if something has a 0 charge or is neutral, then we would never put anything here, because if nothing is here, then it is understood to be neutral. So I've got 2 examples for you. The first one I will do, uranium 238. Okay, so the symbol for uranium is U, and then 238 would be right up there, would be the top left-hand corner, and then we would put 92 right here. Then we've got nickel, and you can do nickel on your own, and then look up when you are done. Okay, look up. So you've got 59 is your mass number, and your atomic number is 28. So remember, the atomic numbers go on the bottom, and then the mass number that's given to you goes on the top left-hand corner. So I hope you understand better atoms and the subatomic particles that go with the atom. Thank you.